Here we discuss a question from CSIR NET December 2024. A spherical cavity of radius r0 has an impenetrable wall. A quantum particle of mass m inside the cavity is in its ground state. The pressure exerted on the cavity wall is. From first law of thermodynamics, we have dq is equal to du plus pdv. Let's use E letter, dE plus pdv. Now there is nothing mentioned about heat exchange, therefore we can consider dq to be 0. Therefore P will be equal to, pressure will be equal to minus dE by dV. Now we need to know the energy of a spherical cavity of radius r0 in its ground state is equal to that of the energy of infinite potential well, that is pi square h bar square divided by 2m r0 square, where r0 is the radius. So this is only for ground state, For excited states, we will have the zeros of spherical Bessel functions and it will not be like this. But it is mentioned here, it is ground state. So you can remember, for ground state, for a spherical cavity, particle inside it, it will have energy pi square h bar square divided by 2m r0 square, where r0 is the radius, similar to infinite potential well energy. Now to get the pressure, we have to find this derivative minus dE upon dV, but E is not written in terms of V, so we can use chain rule and write P is equal to minus dE by dr0 by dV by dr0. So we can use chain rule here. This is equal to minus dE by dr0. Let us first find dE by dr0 is equal to d by dr0 of pi square h bar square divided by 2m r0 square. This is equal to pi square h bar square divided by 2m, this is constant, minus 2 times 1 by r0 cube. Therefore this is equal to 2 gets cancelled, pi square h bar square divided by m r0 cube with a negative sign. Now let us find dV by dr0. This is equal to d by dr0 of volume is 4 by 3 pi r0 cube, which is equal to 3 times 4 by 3 pi r0 squared. Therefore if we substitute these two things, this is equation 1, this is equation 2. If we put 1 and 2, in equation A, let us say this is equation A, then we have P is equal to minus of minus pi square h bar square divided by m r0 cube divided by 4 pi r0 square, which is equal to pi square h bar square divided by m r0 cube times 4 pi r0 square. 1 pi gets cancelled. This is equal to pi h bar square divided by m r0 raised to 5. And there is a 4 also. There is a 4 here. So the correct option here is pi h bar square divided by 4m r0 raised to 5. Option 1 is the correct answer here.